Hey everyone! Welcome back to my Procedural Ruins tutorial series for SideFX's Project GROT. In the previous chapter, we added vertex color masks to our ruins that a shader in Unreal will be able to interpret like a smart material in Substance Painter. In this chapter, we will wrap up the tool and turn it into a Houdini Digital Asset so that we can finally import it into Unreal. Let's get into Houdini! Alright, here we are again, and we have our nicely colored ruins with our flesh, and our work is kinda done, but we still have a last big push ahead of us. And that is, well, we want to turn this graph into an HDA. Let's just take a moment to talk about that. We basically do have a tool already now. We could send this HIP file to a colleague of ours, and they could put any kind of mesh in and paint, and we would get this as an end result, and I don't know, we could save this as an FBX or something. But we couldn't use this tool in Unreal. And the reason for that is because to be able to use a Houdini tool in Unreal, we first need to turn it into an HDA, or a Houdini Digital Asset. HDAs are basically little files that store all of our nodes in a portable manner, and also in a manner that is readable by plugins in third-party software such as Unreal, Unity, 3ds Max. And one thing that we need to be mindful of is that depending on which third-party software we're making the tool for, we need to use different attributes. For Unreal, for instance, we have this list of the special Unreal attributes, and they can do a wide range of things. For instance, we can automatically place materials on parts of our mesh. We can spawn instances, and this includes not only static meshes from our content browser, but also blueprints, point lights, VFX, all kinds of stuff. And if we want to go even further, we can use this Unreal U property attribute. And as you can see, it includes a star because it basically means we can control any Unreal U property, which means parameters on static meshes or on blueprints or VFX. So you can see that there are many attributes, but even just with those three, we can do a lot of things. But I don't want to overwhelm you with all this stuff right now. We're only going to focus on the Unreal Material attribute for now, okay? Because I think this is the most important one, because we always want to have materials on our meshes, right? So how do these attributes work? Working in Houdini, I'm guessing you are probably familiar with the concept of working with attributes. We have point, primitive, detail attributes, and also different kinds: float, integer, string, and these various Unreal attributes also work in these various ways. So for instance, for the Unreal Material attribute, what Houdini and Unreal need to make this work is we need to supply a primitive attribute. So in each polygon, we tell it which material. And that's the cool thing, we can directly link up a material from our content browser. But I'm getting ahead of myself. So let's first turn this tool into an HDA, just to dispel the mystery, right? So what do we have to do to turn a graph into an HDA? The first thing we have to do is we have to turn our graph into a subnet, basically put it into a little box. And to do that, we just select the nodes that we want to include, and note that I'm not including my placeholder mesh. And to put it into this subnet box, we can either press this little box icon up there in the upper right corner, or we can press Shift-C. Now it should be put in this little box here, and our tool is gonna cook. If you don't want to wait for that, you can press Escape, and here we go. Here we have our little subnet. And to now turn this into an HDA, we just hover over our subnet and press right-click, Create Digital Asset. And now this little window pops up. And it might not seem important to you if you haven't done this before, but naming is actually a quite important step in the creation of an HDA, especially if you work in a company and there are certain naming conventions that you have to follow. I still want to follow the GROT naming convention. So what I'm going to do is I'm going to call it GROT Ruins. And you can see that the name adapts right here. So whatever I'm going to type in here, it's going to appear here. And another thing that we can do is we have this tab submenu setting right here. And what that is so when you press right click in your node network, you can see that there are different what's called submenus. For instance, Side Effects Labs has its own submenu. If you created a digital asset, it just gets put into this digital asset submenu. And what we did for Project GROT is we made our own GROT submenu so that, all our nodes are stored in the same place. So I'm gonna stick to that. I'm just gonna remove the name for now. What is really handy also is the version. Because you can imagine you're done with your tool, but you've thought of a really good way to, add a new killer feature or to make it twice as fast. But the old one was working just fine. So to avoid breaking the workflow of whoever is using your already existing tool, it's a good idea to then upgrade to a 1.1 or a 2.0, so you can have kind of the best of both worlds. You have the old one that works, but then you also have the new one where you can go a bit crazy and experiment, and that's basically it. The last thing I want to show you is here where it says save to, we have this path right there. And this is the standard location where your HDAs are going to be saved. So in case you are you're wondering where it will be, this is the location. It's this OTLs folder. But of course you can save it wherever you want. It's up to you, but this is the standard location. And I'm just gonna click create. And now this window popped up. And this is what's called the edit operator type properties window. So this is basically your command center for everything HDA related, which is why I would highly recommend you to familiarize yourself with this window. There's a bunch of different tabs that do all kinds of different things. I'm just gonna go over a few of the ones that I use regularly. So let's just get started with the basic one. For instance, if you made a spelling mistake, it's no problem. You can just change the name here. Minimum and maximum inputs and outputs can also be changed here. The parameters window is, for this lesson, the most important one, but more on that later. The input and output is also nice. We can give the input, for instance, a name. If you want to, we can call it anything, like I call that blockout mesh. And the script section is really powerful. In here you could, for instance, write Python scripts that do a whole bunch of different things, basically anything you want them to do. But as I said, the one that I want to focus on is the parameters window. As you've seen in the previous lessons, we have all these different nodes, and whenever I wanted to change something regarding the look of my ruins, I had to jump from this node to this node, go in here, change parameters and all this stuff, right? So what we should do when we turn our graph into a tool is that we pick a handful of the most important parameters and nodes that we think are crucial to the functionality of our tool, and then we can expose some of these parameters so that the artist that uses our tool has easy access to these different settings. Which parameters and the amount of parameters is up to you. There isn't really a right or wrong answer. I would say in general, it's a nicer user experience if you have as little parameters as possible, but that of course comes at the cost of less control. The opposite also goes for the more parameters you have, the more control you have, but also it might end up feeling a bit clunky. Because now if I want to, just change something really small, I need to affect 3 different parameters. It's just something that you got to figure out through communication and trial and error. And the UI I'm going to build here is also, you don't have to follow along for this 100%. Feel free to pick and choose whichever settings you want. I'm just going to highlight a few of them that I found interesting and include them in the tool. So I'm just going to get started with what I think is the most important one, and that is the detail mode. If you remember in the second chapter, we were building a detail mode for our concrete part. And as we were testing the tool, we noticed that every time I want to make a change, it became really cumbersome and kind of annoying actually to make changes to the visuals, because every time I started painting somewhere, I had to wait between 10 and 30 seconds to see the next result. Of course, that's not what we would want for our artist, and so we made it optional behind a switch. However, to access the switch, we would have to dig in and then change it by hand. So what I would like to do now is to promote that and expose a detail mode parameter at the top level of our HDA. So I'm just going to add a toggle and I'm just going to call it detail mode. And press apply. And now you can see we have this little toggle here. And I can click it and nothing happens because of course we haven't linked it to anything yet. And to link a parameter, what we have to do is hover over it and press right click, copy parameter, and then go inside, and then we need to find the location where we would want to implement this feature. In our case, it was the switch node that we prepared in the second chapter. So I'm just gonna go here, and then where it says select input, I'm gonna press right click, paste relative reference. And now you can see that we see this this green expression here where it says ch and then brackets // detail mode. And what that means is basically, hey, switch node, jump up one level, which is our HDA, and then look for a parameter called detail mode, which is the one we just made. And whatever we're gonna press on our detail mode is gonna be relayed to our switch node. One thing you might have noticed when I disabled it, by the way, you can also disable it the other way around. If I disable it on the switch node, it's also disabled here. So what you might have noticed is that when I disabled the detail mode is that on our low quality mesh, we're still producing flesh over here. This might be intended or unintended. In my case, it's kind of unintended because the flesh is not really a direct representation of what it's gonna look like later. To keep it very simple, I'm just gonna copy the switch node and make it so that if I disable the detail mode, I also disable the flesh. So what I can do in this case is just pass on the switch node, because if the switch is on 0, that means that here it would also pass on the low detail, and in the second input, I'm gonna pass on the detailed result. So if I just connect this up and I disable it now, then we have this completely low detail mode, and if I enable it, now we have the detailed mode with the flesh and all the other stuff. I think that was the trickiest one. So for all the other features, I'm just gonna place a few parameters, and if there's anything specific, I'm gonna bring it up. But basically the way it works most of the time is you just drag a parameter, you come up with a feature that you want to have, for instance the fracture density, and then you set a range that kind of makes sense. I don't know, something between 1 and 50. You press apply, and now you have this new slider, and then we just copy it and go to the right place, so the scatter node for instance, and then we just paste the reference, and here we go. We have our feature linked. Of course, it's easier to check if we disable the detail mode, but yeah, but you get the idea, right? It's not really difficult, it's just a lot of little work. However, what you can do to make it a bit faster and easier is you don't necessarily have to make them all by hand every time. If there's a specific parameter that you want to copy one-to-one that exists already, you can just take it the way it is. For instance, in the RBD cluster node, I like the detach ratio slider that lets me break off some pieces from the clusters, and if I want to, I can just drag and drop it into my type properties window and press apply, and it's immediately linked up and it's already in my UI. This is a really handy way that you can build up a UI from different parameters that you find all over the place. And if you want to, you can even take a whole node and link it up to your type properties. But of course, I don't know when you would want to do this. Maybe when you make custom nodes that you want to use over and over again. And one last setting that I wanted to show before I fast forward through the rest is the shard length. If you remember in the first chapter, we added these two transform nodes that cancel each other out to allow for this nice little cheat where we can make our shards a bit longer. So what we can do is we can make a parameter for that so that we can easily make this into a feature. So I'm just gonna set the range from something like 0.001. For a lot of parameters, I would recommend you to avoid values like 0 because it can often lead to some errors or other problems that you didn't foresee. I'm gonna take my shard length, and in my transform node where I put in my value, I can just go right click, paste relative reference, and in the first transform I can do the same where I had the 3 and just paste it right here. So if I want to, I can make the shards really short like this. That also looks cool actually, or I can make them really long if I want to. And one more thing, if you don't want to keep going copy, jumping in, right click, paste, what you can do is you can also create a second window here under Windows, new floating panel, and you can have this window here, and you can set this to be a parameter and then unpin it, select your HDA and then pin it. And now we can jump in and have an easier time, like, you know, linking parameters back and forth. I'm just gonna do the rest now and fast forward. So I've created and linked up a bunch of different parameters right now, such as the fracture density. The outer shell thickness is an interesting one. So if you remember in the first lesson where we painted a damage, we created this outer shell that we can fracture. I thought it would be interesting to have a parameter to set this thickness so that, you know, depending on the scale of the object we want to fracture, we can adjust it on demand. If we have a very large object or a very small object, it doesn't really matter. The piece removal amount is also cool. I wanna highlight that one also. So if we go back to where we made our pieces, you remember we had this blast node that removes some of them. And the cool thing about the blast node, and I guess group tabs in general, is that not only can we link a attribute value, we can combine that together with a parameter that we have. So we can dynamically access attribute values through a parameter that we have linked up inside this group tab. So I can just remove and add pieces as I see fit. And I think this is a huge feature because now we can really fine-tune the amount of destruction to exactly what we want. Then some other parameters that I made were in regards to the flesh. So if I turn on detail mode, we can check it out. And I just focused on what seemed to be the obvious ones for me, such as the density, the minimum and maximum range, so we can affect the look, and of course the thickness of the flesh, because we don't know what feels right until we see it in the final scene. So yeah, this is pretty neat, but I want to address one thing that's important about parameters, and that is default values. So if I go over here to my little gearbox icon and I go to revert to factory defaults, all the parameters are now set back to their default values. And the reason why I'm doing that is because I just wanted to show you that this is what's going to happen when our tool gets loaded in Unreal. The first time it gets loaded up, it's going to load up the default values. And well, as you see, if we use the default values, nothing is going to happen because I didn't set any default values. Except for the detach ratio, that was the one that we stole basically. And when you take a parameter from another node, it automatically sets a default value. But if you create your own parameters, all of them are going to remain empty. And so what that means is, for instance, if you have a fracture density of 0, no pieces get generated. So nothing happens. And we only get the block out. Also, if I have a shard length of 0, a length of 0 means no shards get generated. Also, if I have an outer shell thickness of 0, then we don't even have a mesh to fracture in the first place. So we need that also. Alright, now something happens. But also, the piece removal is set to 0, so we have no pieces. So, you know, you get the point, right? So what I'm trying to get at is defaults are really important because it doesn't take a lot of time, but it can cause a lot of frustration if you forget about them. Just to make sure that we have our defaults, let's go to our type properties, and then on our parameters, we can set the defaults in the channels tab. So now if I reset it, nice, we always have some kind of value. We have a nice little UI right now, but I feel like at this point, we're kind of starting to enter confusing territory. When all you have is just slider after slider after slider, it starts to become a bit hard to read, but luckily there are some handy parameters that can help us only with structuring our UI. So for instance, folders allow us to group certain parameters together into a tab. I'm going to take all the ones that have to do with concrete and put them into this folder. And I'm going to call this folder concrete. And now if I press apply, it's a bit subtle, but you can now see that they're grouped into this concrete folder. If I get another folder and take all of them and put them in there and call this one flesh and press apply, you can now see that we have a second tab and they're grouped next to each other. So this is much more like what we expect from a normal tool, right? Like that each setting has its own little area. And then there's a slightly more subtle organizing parameter called the separator. So let's say, for instance, that I want a new parameter, a random seed. and I press apply, and I feel like, I don't know, something bothers me that these two are so close together. What I can do is I can get a separator and put it between the seed and the detail mode, and now we have this little buffer right here. It's very subtle, but it just adds a little bit of clarity and readability to the setup. And now I'm just gonna accept, take my seed and link it up with all the necessary nodes. And here we go. Now we have a really nice, simple UI. Feel free to build on top of that if you have more features that you can think of. But I personally am happy with this. And by the way, if you make changes to your HDA, the way that you can save those changes is by hovering over your HDA and pressing right click, save node type. Okay, so one more important thing, and that is what I mentioned earlier, the Unreal attributes. As I've shown for a moment earlier, we have this really extensive list of all kinds of different Houdini attributes that Unreal Engine knows how to interpret thanks to the Houdini Engine plugin. There are a ton of different things that we can do. Don't worry, you don't need to know all of them right now. If you're interested how you can use some of these, I wrote a dedicated article on my personal favorites. Feel free to check it out. But yeah, just to give you a quick glimpse on some of those. For instance, the one that I want to focus on, the Unreal Material attribute, allows us to automatically add material instances to our HDA so that whenever we cook our HDA, it already comes with materials. So how do we get the Unreal Material onto our mesh? It's really quite easy. There's even already a shortcut created from side effects called the Unreal Material node. And if we drop that down, we can see that it's actually just an attribute create, but it already has all the right settings filled in. It's an attribute called Unreal Material, it's a primitive class, and it's of the type string. And that's an important thing to know. Anything you want to spawn inside of Unreal, be it a material, VFX, static mesh, anything in your content browser, is all technically a string. And what we need to supply to these different attributes is the relative path inside Unreal Engine. But more on that in the next lesson. For now, we're just gonna prepare it so that whoever is using our tool is able to dynamically swap out the material how they see fit. To do that, all we have to do really is just drop it in there and then get our parameter interface. And as we learned before, we can just take the string parameter and drag it in here. And we can give it a name such as Matte Concrete and press apply. And it's linked up. Then I'm gonna get another Unreal Material and do the same for the flesh. And that's it. That's all we have to do. Remember to accept and then press save node type. Yeah, so all we have to do now is get it into Unreal. And that is gonna be our next and final chapter. I hope this was informative and that you had fun, and see you in the next one. Bye bye.